Hi students, this is Ms. Johnson with 4-4 Parallel and Perpendicular Lines. Our SWABAT is we are going to write equations for lines that are parallel and perpendicular to a given point. Alright, first of all, let's refresh ourselves with what parallel and perpendicular lines are. Parallel lines are lines that do not intersect, ever. And if they do not intersect, that means they have the same slope. And the symbol for parallel is two lines right next to one another. It looks like the number 11, but they're even closer, so it means parallel. Vice versa, perpendicular lines are lines that do intersect, and they intersect at a 90-degree angle. And when lines intersect at a 90-degree angle, their slopes are going to be the opposite reciprocal. And the symbol for that is a line going straight up and straight across at 90 degrees. For example, if the slope of a line is 4 and it's perpendicular to that, the opposite reciprocal, this one is positive, the opposite is going to be negative. And if the slope is 4, remember whole numbers are 4 over 1. Reciprocal means a fancy word for flip-flop. So instead of 4 over 1, it's going to be 1/4. So if the slope is 4, the opposite reciprocal is negative 1/4. Alright, let's go ahead and look at what an example would be for this. Example number 1. Write an equation in slope-intercept form for a line that's parallel to y equals 2x minus 4, and it has to go through the point -3, 5. Alright, for the visual, here is the graph of y equals 2x minus 4, and we are trying to find the equation for this line that is parallel. Notice the lines are parallel, they won't ever intersect, and they have to go through the point -3, 5. So -1, 2, 3, up 5 right here. So here is the line that we are trying to find the equation for. And I'm sure this is used all the time with engineers and building roads, that roads have to go through a certain town at a certain spot, and they want the roads to be parallel to other roads. Alright, here's what we're going to do, is we're going to start with point-slope form. Okay, and reminder, point-slope form, that's our y minus y1 equals m times the quantity of x minus x1. Alright, knowing that, we are going to substitute in a point for our x1 and y1, since we have that point, x1 and y1, and since we're looking for a line that's parallel, that means we're going to have the same slope from our equation. So our equation, y equals 2x minus 4, has a slope of 2. So that means our new equation is also going to have a slope of 2. So if we substitute this in to our point-slope form, we've got y minus y1, and our y1 value is 5, so we've got y minus 5. And then we have our slope, which this one was 2, so our new slope needs to be 2. Parentheses, then we've got our x minus x1. Well, minus and our x1 is -3. Remember, when you subtract a -3, it means the same thing as adding. Subtracting a negative is adding, so we can just turn that into +3. Alright, once we have substituted our point and our slope into point-slope form, they want us to write an equation in slope-intercept form. So now we need to manipulate our equation, so it's going to be in the y equals mx plus b. So first thing we need to do is we need to distribute to get rid of our parentheses. So we're going to do our 2 minus x to get 2x, and 2 times 3 to get 6. So now we've got y minus 5 equals 2x plus 6. To get the y by itself on our left-hand side, we need to add 5. And of course we need to do that to both sides. So now we are left with y equals 2x plus 11. And that is the equation for this line. Y equals 2x has the same slope as this line, and it's plus 11. If we were to extend our graph, our y-intercept would be up here at 11. There you go. That is how you write an equation for a line that is parallel to another line and going through a certain point.